Good afternoon. I'm Junbom from South Korea. First of all, it is an honor to present my research result in this live session. Today, I'm going to present about Mirabegron effect on inhibition of sensor sensitization induced by overactive bladder mice model. This study is funded by Astellas. It is well known that most of people who suffer the overactive bladder have been treated with an agent such as anticholinergics or beta-3 agonist, but there has not been revealed pathophysiologic evidence explaining how long OAB medication should be taken and continued. We used bladder-centric OAB animal model, which was induced by repetitive bladder irritation and inflammation. In this situation, bladder afferent pathway is hyperexcited. Many studies reported that afferent hyperexcitability may induce neural remodeling of the central nervous system. In this study, we tried to investigate it to verify central sensitization in our OAB mice model. Second, we investigated whether Mirabegron affect neural remodeling in CNS or not. Additionally, compared the result between treatment cessation and continuation. Female C57 blank mice were used and divided into four groups. For inducing OAB, potassium chloride mixture with hyaluronidase was instilled intravesically for 1 hour under anesthesia. For sham mice, saline was instilled with the same manner. This was conducted 3 times 1 week interval. Then, Daegu was administered in OAB mice. 2 mg per kilogram per day of Mirabegron was implanted using osmotic pump in treatment cessation and continuation group. In cessation group, osmotic pump was removed on day 10 from implantation. After 20 days, Cystometrogram, RT-PCR, and immunofluorescence study were conducted. Let's see the systematic results. In OAB group, intercontraction interval, non-voiding contractions, bladder capacity, voided volume, and voiding efficiency were significantly worse than in sham group. In treatment continuation mice, these parameters were all improved compared to OAB mice. Moreover, non-voiding contractions and voiding efficiency showed better improvement in continuation group. In OAB group, M2, M3 muscarinic receptors, beta-2 and 3 adrenergic receptors, and P2X purinergic receptors were overexpressed compared to sham group. But beta-2 and 3 and P2X purinergic receptors showed decreased expressions in continuation group compared to OAB group. Particularly, beta-3 receptors showed more reduction in continuation group compared to cessation group. In previous studies, CCL2 and CCR2 in dorsal root ganglion and dorsal horn of spinal cord were reportedly associated with sensor sensitization. In our results, CCL2 and CCR2 of L6S1-DRZ were upregulated in OAB group, but downregulated in treatment continuation group. CCL2 particularly showed significant changes in continuation group compared to cessation group. Together with the systematic results, the increased expressions of muscarinic, beta-adrenergic, and P2X purinergic receptors in bladder urothelium and upregulated CCL2 and CCR2 of L6S1-DRG indicated bladder overactivity and afferent hyperexcitability respectively. Continuous treatment of Mirabegron improved bladder overactivity, and afferent hyperexcitability. Lots of studies reported that glial activation is known to play an important role in central sensitization. CX3CL1, a microglial marker, and GFAP, an astrocyte marker, and chemokine receptor CCR2 were overexpressed in OAB group. All these markers in continuation group showed reduced expression. In addition, CX3CL1 and GFAP were significantly lower in continuation group versus treatment cessation group. Our results represented the strong possibility that sensor sensitization and long-term afferent potentiation may be involved in OAB mechanisms. Continuous Mirabegron interfered with central sensitization, evidenced by decreased immunoreactivity of CX3CL1 and GFAP in L6 spinal cord. This is conclusion. Central sensitization may be an important pathophysiologic mechanism of OAB. Continuous treatment of OAB with Mirabegron seems to prevent the process of central sensitization via improvement of CNS neural remodeling, evidenced by decreased expression of CCL2 and lower expression of CX3CL1 and GFAP. Therefore, continuous OAB medication may be desirable for long-term disease control. Thank you for your attention.